Hello class. In this lecture I will talk about hypothesis testing. So I will be talking about in this lecture Z-stat. So this is usually used when n is greater than or equal to 30 and the population standard deviation or variance is known. So this is standard deviation. So I will try to solve a problem and this will be a two-tail problem. So previously I discussed about one tail and two tail. So a two tail is we are evaluating on both sides of the curve. So we look at both sides of the curve. This is if this is negative z alpha over 2, this is positive z alpha over 2. We just wanted to evaluate our hypothesis on both sides of the curve. For one tail, we will be only looking at one side of the curve. So this might be negative z alpha over 2. So we will be r. There is another situation which is positive z alpha over 2, and we will be evaluating our uh, hypothesis. So once I have this, I will kind of now start with a two-tail problem and try to solve, try to do hypothesis testing. Again, this is Z-stat when n is greater than or equal to 30 and sigma is known. So a president of a university, so this is our problem. A president of a university claims that the weight of students in the university is 160 pounds. So now we wanted to check whether this claim by the university president is true or not. So if you see, this is the president is claiming this for the entire university. So this would be our population mean, which is 160 pounds. So this is first chapter in which we talked about if we claim about the entire population, then that will be a population mean. So the first step of hypothesis testing is to define your hypothesis. The first step of hypothesis testing is to define your hypothesis. So here we have I discussed about null hypothesis and alternative. So a null hypothesis, whatever the claim is made, that is old theory or old phenomena. So usually the president is claiming that the weight of the students in the uh, university is 160 lb, so that will be, or 160 pounds, that would be your null hypothesis. Your alternative, so if this is equivalent to 160, alternative will be not equal to 160, so that would be your alternative. So again, the president claims that it's 160, so that means this should be equivalent to 160, and the alternative would be not equal to 160. So in here, one of the things is why this is a two-tail. By saying this is equal to, the president is claiming that the university's student body weight is exactly equal to 160. So that means if it is less than 160 or more than 160, then the president's claim is false. So that means we can disprove the president's claim on both sides of a normal distribution curve. That's the reason it is called two-tail, because we can disprove if it is less than, the president is the president claim is false. Same if it is more than, that means we are trying to uh, disprove the president on both sides. That's the reason why it is a two-tail problem. So once we define the hypothesis, now we kind of need a data we will collect. So we wanted to verify whether the president's claim is true or not. So we will be collecting the data, a sample from the university, and try to analyze it. So all this will be given. So this is, we are collecting the data. Suppose our sample size, we take 49 students and calculate their mean weights, and it turned out to be 158 pounds, and the standard deviation is known and it is equivalent to 4 pounds. And we wanted to know at a confidence interval of 95%. So sometimes they will give you confidence interval, or at times they will directly give you significance level. So we discussed significance level previously, which is 1 minus 0.95, that is 0.05. So they will give you alpha. So they can give you one of these. They will either give you confidence interval, or from now onwards they will kind of give you a significance level of 0.05. So this all is given. Now the second step of hypothesis testing is to do test statistic, is to conduct test statistic and compare it with critical value. So as you know, that the sample size n is 49, which is greater than 30, and your sigma is known. That means these two together are suggesting us to use Z-stat. So I will use Z-stat. The formula for Z-stat or Z-score in test statistic is x bar minus mu sigma over root n. So our x bar is 158, and then this mu will be population, so that will come from h null value, which is 160, and then sigma is known, which is 4, and n is 49. So this will be equal to 158 minus 160 divided by 4 over square root of 49. So this you should get negative 3.5. So the next step would be your critical value. How do you calculate critical value? They gave you significance level or confidence interval, which is confidence interval suppose is 95%, so you can calculate significance level, which is 1 minus 0.95 is equal to 0.05, and I wanted alpha over 2. So this will be, so since this is a two-tail problem, we are interested in knowing z alpha over 2. So alpha over 2 would be 0.05 over 2, that is 0.025. So this in our normal distribution curve, this is how critical value will look. So I have a normal distribution curve, and this is our mu, which is 160, and this is negative z alpha over 2, and this is positive z alpha over 2. So this is confidence interval, which is 0.95, this area, and then this area plus this area together would be our significance level alpha, which is 0.05. so each of these areas, so this would be 0.025 and this would be 0.025, that is alpha over 2. Since we are considering a two-tail problem, this is a two-tail problem, alpha is split between the two ends. So that's the main idea. So if this is mu 160 is this curve actually represents what the president is claiming. So when we say 95% confidence, that means it should be around what president is claiming. So if your z value, this z stat value, negative 3.5, or so if it falls in this area from let me use a different color, from here to here, if it falls in this area, you say do not reject H null. So that means if you see our H null is, our claim H null is mu is equal to 160. So if we don't reject that, that means that's true. If we do not reject that, that means the claim of the president is true. So this means the claim of a president is true. And if it Maybe I will use a different color. So if it falls somewhere here or here, your z stat value, this negative 3.5, then you reject H null. That means the precedent's claim is false. So you reject H nulls. This means the precedent's claim of 160 is false. So now the first thing in this is to calculate this z negative alpha over 2 and this positive z alpha over 2. So I will go z alpha over 2, that is z 0.025. so I need to calculate this value. So what is this? I will go to the statistical table and try to calculate, and usually statistical table is going to give me left side of the curve. So when I look at z 0.025, it's going to give me this. So I will go to my z table. So you can go to modules of your class and then go to calculation aids and download statistical tables. Do enable editing, and then currently we are in Poisson table, so I need to go to z table and look for 0.025 probability. So I will go and look for 0.025 is this value, so that is negative 1.96. so that would be negative 1.96. so I will go here to my Word document, and this value is negative 1.96. so this is, if you see this is negative 1.96 and this is positive 1.96. Now you go and look for your z value from test statistic. So that z value is actually negative 3.5. so if this is negative 1.96, negative 3.5 will lie somewhere here. So this would be negative 3.5. so if you can clearly see after this point it's a rejection region, so it's falling under rejection region, so we are saying reject H null. So what this means is this statement is not true. So that means the manager's or the president's claim is not true. So we can write our conclusion would be there is insufficient evidence to claim that the mean weight of students in the university is 160 pounds at 95% confidence interval or significance level of 0.05. So there is no sufficient evidence because you are basing yourself on a sample. Your sample is saying that there is no sufficient evidence, so that's why you are writing insufficient evidence. So we have finished this. So now let's try to solve the same problem using calculation aids. So in these kind of problems, the first thing is determining whether it is z score, z stat or t stat, especially with mean problems, is important. So z stat, you use n greater than or equal to 30 and sigma is known, which is population variance, standard deviation or variance, and then you have t stat, which is n less than or equal to 30 and sigma is unknown. So currently our problem, if you see the problem which we solved, has n of 49. So I will note down these values such that we can solve in calculation aids. So n is 49, x bar is 158 and sigma is known, and this is equivalent to 4, and your significance level which is alpha is equal to 0.05, and then your hypothesis is mu is equal to 160. Alternative hypothesis is mu not equal to 160. So this is when you see an equal sign here, it's, you would know it's a two-tail problem. So this equal sign. So now I will download our calculation aids of chapter 10. So I will go to chapter 10. Again, you are going to modules, module 0, calculation aids, module 0, calculation aids, and try to download chapter 10 material worksheet, and then so you will do enable editing. Currently you are in proportion test. Now you have to go to mean test known variance. So if you see in this, we have three cases. Case 1 is one tail, case 2 is also one tail, case 3 is two tails. So we are currently doing this two tail problem. So let's look at what is the population mean. So the population mean is 160, so that is mu is equal to 160. So I will do population mean, I will enter 160 here. Let me see. Okay, so population mean is 160, population standard deviation what is population standard deviation? So let me see. population standard deviation is 4, so I will enter that. This is 4, and then the sample mean our x bar, so this is our x bar, so that is 158. So this will be 158, and then alpha would be, so significance level alpha is 0.05, so this is 0.05, and then finally sample size is 49. And hit enter. So if you see, our test statistic value negative 3.5, and then our critical value is 1.96, and then it is asking us to reject H null. So when I say reject H null, that means the manager's claim is false. So that is how you will be solving a two-tail problem. So let's go to Hawk's learning and try to solve one problem on this. So I will go here. Okay, this is Hawk's learning. So a carpenter is making doors that are 2058 millimeters tall. If the doors are too long, they must be trimmed, and if they are uh, too short, they cannot be used. So a sample of 11 doors is made, and it is found that the mean, I think it is a one-tail problem. I will skip this one. Let me try to find a two-tail problem. So okay, so this is a different concept, so let me okay, so this problem is a two-tail problem, I think, and with Z stat. Let me read the question. Using traditional methods, it takes 98 hours to receive a basic driving license. A new licensing method using computer-aided instruction has been proposed. A researcher used the technique with 70 students and observed that they had a mean of 96 hours. The standard deviation is known to be 6. The level of significance is 0.02 will be used to determine if the technique performs differently than traditional methods. Okay, so one of the things I wanted you to understand is this is a Z problem because we have 70 students, so the sample size is greater than 30, and then I have a standard deviation which is known to be 8 to be 6. So the standard deviation is known, so this is a Z-stat problem. Now whether it is a two tail or a one tail, how do you determine that? In this they are saying this is performs differently. So when they say something like performing differently, that means it's a two tail problem, because differently means it's both lower or upper value. So that's how you determine it's a two tail problem. So I will go and note down these values on our Word document. So this is Hawk's learning. So the first thing is, using traditional methods it takes 98 hours to receive basic driving license. So this is a traditional method, that means it's a old system. So our mu would be, or population mean, mu is 98 hours. So maybe hours I will write. Okay, so what's next? So they are implementing a computer aided instruction. So a researcher used the technique with 70 students. So they took a sample of 70 students. So our n is equal to 70, and then they observed that they had a mean of 96. So the sample mean is 96 hours. So x bar is 96 hours, and then assume the standard deviation is known to be 6. So your standard deviation, which is sigma, this is known and it is 6. So, and then significance level alpha they give. .02. So this is a two-tail problem. So our hypothesis will be mu is equal to 98, and alternative would be mu not equal to 98. So that's the reason why, because they said different, so they kind of so they said perform perform differently. So when they say differently, you can kind of disprove both sides of the normal distribution curve. So I will take these values to our calculation aids and try to calculate. Maybe I will open a new calculation aid and calculate it. So I will go to our modules and download chapter 10 calculation aids. Again we are dealing with, so this is proportion test anyways, proportion test. We are in the spreadsheet of proportion test. We wanted to do mean test with known variance. Again we wanted to do a two-tail, so this is our interest. So let me see what is the population mean. So the population mean is given as 98. So if you see, that's population mean. So I will type population mean as 98. Population standard deviation, population standard deviation sigma is 6. So this will be 6, and sample mean is x bar, which is 96. And then alpha significance level. So let's see what is the significance level given. The significance level is 0.02. So this means this also means 98% confidence interval. So significance level is 0.02 and the sample size n is 70. So I hit enter. So we got our test statistic value, we got our critical value, and whether we wanted to reject, what should we do? They are asking us to reject null hypothesis. That means this statement is false. So that means the new system, the mean hours is different from 98. So let's see the question, what it says. So they're asking us, the first question is to enter the test statistic value. So the test statistic value here would be negative 2.78 or negative 2.7888. So let me see how many decimals they are asking. So this would be negative okay, so it's not taking negative value. Okay, so it's a two tail, so you just type in 2.78. So because we can kind of uh, disprove on both sides, so it can be negative 2.78 or positive 2.78. I think that's the reason. If it is a two tail problem, it will just take 2.78. Okay, let me try again. I wanted to put negative then. I'll use keypad to put negative. Okay, now it should be right. I think it will directly take negative 2.78. Yeah, so just type in the exact value. I don't think there is both sides phenomena which can be used, so just type in negative 2.78. How about the next one there? So let's see this problem. A manufacturer of chocolate chips would like to know whether its bag filling machine works correctly at 448 gram setting. It is believed that the machine is underfilling the bags of 40. Okay, so this problem is a one tail problem because it says underfilling, so I will skip this. We'll skip this also. I think that's the only problem I could come across in practice. Okay, I don't think there are more problems on this. Yeah, so this is same as which we did. Okay, so I don't think, let me go and see if I can find some more problems, one more problem on this certify and see if I can solve that. I will just take hits for some of these problems such that I can get two tail Z problem. Okay, it's the same problem like which we did. Again, it takes. So we'll do this problem and try to end this lecture. So this problem says using traditional methods it takes 92 hours to receive basic driving license. So they have a new license training method using computer aided instruction has been proposed. A researcher used the technique with 70 students and observed that they had a mean of 90. Assume that the variance is known to be 49 and a level of significance is 0.02. So again, because they are saying it's a tradition using traditional method, it takes 92 hours. So your mean mu is 92. That's what the question is saying. And then we have a researcher used a technique with 70 students. So your sample size n would be 70. And then he observed that they had a mean of 90 hours. So x bar is 90. So x bar is 90, and then assume that the variance is known to be 49. So they gave you variance. So that means variance is sigma square, which is 49. So you want sigma, you do square root of 49, that is 7. So your sigma is 7. And then we wanted alpha. They wanted us to calculate a level of significance of 0.02. So you will do alpha is equal to 0.02, and then we have to determine whether it is a one-tail problem or a two-tail problem. So they say if the will a level of significance of 0.02 will be used to determine if the technique performs differently than the traditional method. So when they say differently, it's you can disprove them both sides of the normal distribution curve. So your hypothesis H null will be mu is equal to 92, alternative will be mu not equal to 92. So I will take this and enter these values into our calculation aids, and you should be getting those values. I will close this calculation aid and open a new one. So go to chapter 10 calculation aid and download it. Do enable editing. Currently we are in proportion test spreadsheet, so we wanted to go to mean test known variance. So the reason why we are going to this spreadsheet is, if you see here, your variance is known. They gave in question this is known. So if you can see in the question, they say variance is known. So that's what they are saying. So I will go and copy my values to our calculation aid. So your population mean is 92, so I will enter population mean. Here it is 92, so this should be 92 population standard deviation. That's 7, so I will enter 7 here. And then sample mean. Sample mean x bar is 90, so I will enter that. And then this alpha value significance level, alpha is 0.02, so this value is 0.02, and the sample size so let me see what is the sample size. Sample size is 70, so I will key in 70. So we got a test statistic value negative 2.39, critical value 2.32, and we reject our null hypothesis. So one of the things is we reject null hypothesis, that means this is false. So then you will kind of say there is insufficient. So this is, I'm trying to explain, if you have to understand what this means. There is insufficient evidence to claim that the mean that's the mean driving license time, new driving license training time is 92 with new system. So this is, I'm just giving you, if there is some statement they wanted you to write, then this is what you will write. So currently in our problem the question is different, so let's go and check what is our question. Determine the value of test statistic. So the test statistic value here would be negative 2.39. So I will enter negative 2.39. Negative 2.39. So that is how you will be solving these kind of problem. This concludes my lecture on Z stat with two tail a two tail problems. So thank you.